okay? So standard error of the mean. This is really important. So standard deviation was all about your data. It's the data that you've collected and hopefully had a large sample size, and you took the average of that sample size. But now I want to go to the population, and I want to know how much error there might be in my data set when I start to compare this to the whole population. Okay, how well does this data represent the whole population? And the larger the number of samples I have, the smaller my standard error of the mean is going to be. The more variability I have, remember, more variability will mean a larger standard deviation. So the more variability I have in my data, then the higher standard error I might have. We want to have confidence at 95%, okay? That our mean, that where we think the average is within at least 2 standard deviations of it. So of all this data I've collected, so 95% of my data is within 2 standard deviations. I want to have confidence that the mean is actually within those values. And that's what standard error of the mean is going to tell me. To calculate it, all I do is take the standard deviation that I already calculated, and I'm going to divide it by the square root of how many samples I took. Okay, so the more samples I take, the smaller my error will be. The more variation I have, the larger my error will be. So if my average is 20 and my standard deviation is 7.7 and the number here is 7, I don't even need the average. I'm just taking 7.7 divided by the square root of 7, which is 2.9. So that means that if my average is 20, I'm going to add or subtract 2.9 to that, and usually times 2, because we go 2 standard errors of the mean. And that's going to give me, I'm going to have a lot of confidence that the average is actually within those values. So we are going to use this standard error of the mean to draw error bars. Error bars are on bar graphs, and what we do is we draw the bar graph at the height of the average. So the height of the bar is the height of the average. Then at this spot, we go up times 2 for our standard error of the mean, and we go down times 2 for our standard error of the mean. Up times 2 and down times 2. Okay? So, what you need to know, and this is really important, if the error bars overlap, so if I'm looking at these 2 data sets and they overlap, then it tells you that those 2 groups, it is not statistically significant that their data, that something is causing the difference in their data. If the error bars overlap, you accept the null hypothesis that it's random. If the error bars do not overlap, then you say it is statistically significant that the reason for all these birds have longer beaks than these other birds. Okay, it's not just random. So if you see a large overlap, then you see that they're not significantly different from each other, and that the difference is due to randomness. And if you see no overlap, then you say the difference must be real. Okay, so in here, which data set has the larger range? Again, a range is the width. So B would have a larger range than A. Which one has a greater standard deviation? The width of the range is the standard deviation. So again, B is going to have a greater standard deviation. A higher mean, I got tricked on this. The mean is going to be not the height of the curve, but where on the x-axis this falls. So if you think of these as being numbers, this is 2, 4, 6, 8, 10, 12. I would say, oh, this one's average is 12, and this one's average is only 6. So you'd say B has the higher average. But the higher frequency would be over here, so A would have that. So again, if you have a large overlap with your data, with these curves, then there's no significant difference. It's due to chance or randomness. If you don't have a large overlap, the results are likely to be significant, okay? So you accept what we call the alternative hypothesis and not the null hypothesis. So which sample is a better estimate of the population, of its population's mean, B or C? So if it's a better estimate, it means that it has smaller error bars. So which one has smaller error bars is going to be C. Identify the two populations that are most likely to have statistically significant differences. So I'm looking for, are there two populations that really don't overlap? And this would be easier to see with a grid. I would say it's D and C, but it's kind of hard to tell. Maybe it's A and D. I need a grid on here to see that, but you're looking for which ones don't overlap. All right, a student notices that the ivy leaves growing on the shady side of the building are larger than the ones growing on the sunny side, and they start to collect it. So the question is this due to randomness, which would be the null hypothesis, that there's no difference really between them, or is there a reason? So you collect all your data. Here's my average, my mean. So the shady ones are 7.43, the sunny ones are 5.88. The standard deviation is 1.63. Okay, so I just add this to this value with my calculator, okay? The number of samples I took was 30. I took 30 leaves from shady, 30 leaves from sunny. And my standard error is 0.3 here, 0.24 here. So looking at this, I can tell already that this one has more variability in it because I have more, this is a higher number. If your number of samples is the same and your error is greater, it means that it has a more variable collection. Okay, there's more differences in sizes on the shady leaves. So so if my standard error is 0.3 and I like you to graph 2 standard errors, that's what they want on the AP test, then I'm going to just multiply 0.3 times 2 and get 0.6. And then I'm going to add this value to the standard deviation, or sorry, to the mean. So 0.6 plus 7.4 plus 0.6, and I'm going to subtract it, 7.4 minus 0.6. So when I graph it, here's my 7.4. This line is at 7.4. If I go up 0.6, that would be 8. So I would draw a dot right here, and I'd go up to 8. And then 7.4 minus 0.6 would be, oops, I went the wrong way, would be, I'm trying to look at this, 6.8. Okay, so 6.8. So it's telling you here, this one went from 8 to 6.8. This is 5.8 plus 0.48, so it's almost 0.5. We'll make that 0.5. So 6.3, use your calculator. I don't do these well in my head. Yeah, 6.3 would be the highest. And then I subtract it, 5.8 minus 0.5, 5.3. So this should be at 5.3, this should be at 5.8. Okay, which actually it's right in here. So this is telling you that 7.43, which is the average, minus the 2 standard errors of the mean, is still greater than 5.8 plus 2. So it's telling you that the bottom, this is a really long way of saying that the bottom of this point is still higher than the top of this point. And therefore, I say that they are statistically significant. All right, so that is going through that whole slideshow. Your homework was to do this worksheet on the standard deviation and standard error of the mean. So when you do this worksheet, you are going to do this in Kami. And I'll kind of talk through it real quick. So I need to take this data. The first thing you would want to do is write this in order from smallest to largest. To find the median, that would be the middle value. So if there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 values. So the median would be the value between the 5th and 6th. So whatever the 5th and 6th value are, so if one's, I don't know, 7 and the other one's 8, it would be 7.5. It's the average of those two. The mean is the average of the whole group, and the range is from the smallest to the lowest. What was confusing kids here? Here I have data. I need an average. Write the same number in all of these columns. then subtract this 5.4 minus the average gives me this, and then multiply this squared, and that gives me this one. So do that for all. So 7.2 minus the average, whatever this average is, it's 7.2 minus that, then square it. Add up all of the squared values. The number of n is the number of samples that goes here. N minus 1 is just subtract that. And to find your standard deviation, you've added up all of these. It's this value divided by n minus 1, and then take the square root. Okay? To find the standard error, that is the standard deviation divided by the square root of the number of samples. Do the same thing here for group B. Same value for all the means, subtract it, square it. All right. Interpret the standard deviation in the context of the problem. So I guess it's probably asking you which one is more variable. Okay, so which group is more variable? Calculate the standard error of the mean. So then I want you to graph it. You are always welcome to, like, if your value's like between 6 and 8 and you really want to get into detail, you could make a break and then starting like writing it up at like 6.1, 6.2, 6.3, because then you can kind of show it a little better. Whatever your average is, so let's say my average is 7. My bar graph, I'm going to make 2 bars, okay? So this is going to look like this. I need a scale, so make a scale, okay? And I'm going to have group A, and I'm going to have group B, like that. And then I'm going, this value right here, the values there are the means, so whatever the average is. And then I'm going to put my error bars. That's my standard error of the mean. I'm going to go up times 2 and down times 2. So whatever my standard error of the mean, I'm going to multiply times 2 and add it to the average. And that's the height of this bar, and subtract it from the average, and that's there. And then I'm going to do it on the other one. Add it and subtract it. Okay? Then I'm going to compare. Is there overlap? So the conclusion, is there likely to be a significant difference between the, and you finish it up. We kind of left off that sentence. So, is there a significant difference? If they overlap, the answer is no. If they don't overlap, the answer is yes. Okay? So that's what you're doing there. And then you need to watch those 3 Edpuzzle videos. Okay? I see you guys again Friday, so don't forget M&Ms for Friday.